Assalamualaikum and greetings to all. We are from Group 5 and we're going to present on our flash flood prevention device, which is water diverting system for subject System Design SEMM 4533 Session 1. To start, our group consists of 5 gentlemen. First, Mr. Amir bin Azman, Ahmed Arief bin Yusof, Zhen Yi, me myself Faris bin Hafis, and last but not least Muhammad Aiman bin Zakaria.
I'm going to tell you the content of our presentation. First, we are going to discuss the function decomposition. Next, the morphological chart. And next, the individual concept from our 5 team members. And the scoring matrix, the modified concept, the screening matrix, the final concept, the FMA and FMEA. And lastly, the detailed design.
This is our function decomposition, starting with geographic clogging drain. Next is flowing, sensoring, filtering, pumping, storing, and lastly the output, which is to maintain the water level.
I'm going to explain about the morphological chart. There are 6 designs that have been generated from our team members for each sub-ideas. As you can see from the sub-idea flowing, the final concept is the combination of the third and fifth solution. For sub-idea sensor, there are few sensors that have been considered such as net tension sensor, flow rate sensor, and water level sensor. And for filtering, we have different type of filters considered in our morphological chart. For sub-idea pumping, 6 different specifications with different horsepower, pump flow rate, and other have been considered for our project. For sub-idea storing, a few net placement and material were discussed. This is the individual concept made by myself, Ahmed bin Yusof. For this design, the pump is used to increase the flow rate of the water in case of blockage due to waste. The net will store the waste and will remove once the maximum capacity of storage is reached. The barricade is implemented to divert the water flow to make sure all water plus waste must pass through the net to be filtered. A flow rate sensor is mounted on the drain after the net to sense the low rate of flow, which would indicate blockage and maintenance are needed.
Assalamualaikum, my name is Amir and this is my individual concept idea. Okay, in this design, having a netting system to collect all the waste that may be in the drain system and water pump to help improving the flow rate of water in high rise. Okay, first the concern that been raised during the discussion with my groupmate is the suction inlet diameter, whether the sizing of the inlet is enough to cater the flow rate of water that is required. Then next is the position of the net that is being too high because I designed it to have a filter below the netting system. And the concern is that waste may be pulled up in front of the barricade. Next is the positioning of the sensor, whether it is efficient enough to trigger the pump to being operate. And lastly is the uh, design of the inlet itself, whether it is safe to protect the water pump, because the concern is that small waste and light may be caught up inside the motor.
Assalamualaikum. My name is Faris bin Hafis. Okay, now I will explain about my individual concept. So as you can see, this is my initial individual concept design, which consists of 3 primary components of my design proposal, which are the netting system, water pump, and the tension sensor that will be placed on the net. The net will be served as waste storage, and when it reaches the maximum capacity, it will physically remove and replace with a new net. So why is the tension sensor present? Its purpose is to provide a reading and alert us when the net has reached its maximum tension and can no longer contain waste. Therefore, we must act and remove the net before something worse occurs. So in addition, the tension sensor is also our IoT technology, which is Internet of Things, as it may notify us via Blink apps. And the next component is the pump, our main components, which will activate when the water pressure is low due to waste fill netting system. So this is because when the net is full of trash, the water flow will be slow since the drain is locked with trash. Therefore, the pump will ensure the water flow is unobstructed.
Hi, my name is Zhen Yi. This is my individual concept design of drainage system to prevent trash and other debris from flowing through the system. The net that is a physical barrier that prevents the trash from passing through the drain and entering the waterway. The system also includes a row of steel bars that are positioned upstream of the net. The bars are designed to trap any larger lightweight debris that may pass through the net during the periods of high water flow. To prevent the accumulation of water within the system, a water level sensor is installed to detect when the water level is too high. When the sensor is triggered, a water pump is activated to discharge the water to another location.
Okay, for this design, the designer's purpose is to materialize the subfunction in the function decomposition. The subfunction which consists of flowing, filtering, sensoring, pumping and storing. This step used to transform the input, which is in this case the clogged drain, with waste input into the output, which is collector waste to prevent the blockage. For flowing, a front barrier is created which consists of some railing type design as the above part and a big hole at the bottom part. The purpose of such design is to allow the big waste to go into a big hole while the top part filter the waste and allow water flow through them only. For filtering, the rear barrier is created which consists of only railing like design. This is to trap the waste from escaping, thus allowing waste from flowing through it. The sensor used in this design is an inductive sensor which can detect the waste accumulated between the front and rear barrier so that the operator collect them when it is needed. The pump is also used to pump water in drain quickly so that the water can flow smoothly inside the drain. Moving next is the scoring matrix. We can see we have 5 columns since we have 5 members in this group. For selection criteria, the first 5 is related to the power function decomposition, and others consist of rigidity, storage capability, material lifespan, safety, and effectiveness. From this metric, we can conclude that Aiman's design has win and will be set as a datum for the second matrix.
This is my modified concept. This design is an improvised design, and the changes that have been made to it include moving the pump to a different location so that the flow of water can be optimized. The placement of the net has been modified by the attachment of additional hooks to it in order to increase the firmness of the net so that it can hold firm under maximum load. In order to have a more accurate detection of the flow rate, the sensor position has been changed in order to ensure that the barrier does not collapse when subjected to pressure. The design of the barrier has also been modified to increase its thickness.
Okay, this is the modified version of my concept idea. First, regarding the inlet pipe for the water suction pump, I designed it to facing downward for the waste not being directed into the water pump, and I add a filter in front of at the entrance of the suction pipe so that the waste and debris will not easily be caught up in the water pump system. Okay, as for the barricade, I make a bigger net, therefore it require a higher strength to hold all the weight being collected, and plus the waste will be pushed by water, so I add up a structure to help to improving the strength and durability of the barricade. And then for the water level sensor, based on the research, I believe I can use the float sensor, which is also a water level sensor, to help and trigger the water suction pump.
Okay, now we move to the modified concept design. As you can see, I still maintain the concept of simple and stronger, where the additional modifications to this new design are intended to make the netting system stronger and firmer, as well as to inspire buyer or customer confidence in our concept. So the change I propose involves adding more hooks or clips to the net's upper level and two stands to support the net's lower level. So this is to resist stronger water flow during heavy rainfall. Plus, when the net is full of with trash, it will hold it until the sensor gives notification to the person to take actions with the trash. So this is because our case study, which is at KSL Resort City, the flow of drainage is slopey and steep down. So it will consist of heavy flow rate of rainwater. So in addition, the tension sensor is positioned in the middle of the net, and to make things more practical, our pump will be placed beneath the sensor.
This is the further modification of my individual concept. The modification is to protect individuals from potential injuries during maintenance. Specifically, the upper part of the steel bars, which are positioned upstream of the net, have now been covered. This modification helps to prevent individuals from coming into contact with the steel bars, which may have sharp edge and pose a risk of injury. Additionally, the water pump has been moved to a position before the physical barrier because the water level will rise faster upstream of the physical barrier when the net is full of trash. This can cause the water flow to slow through the net and in turn slow down the rate at which water is being discharged downstream of the physical barrier. By relocating the water pump to a position before the physical barrier, the system is able to quickly and efficiently remove excess water from the system, even when the net is full of trash.
For the modified design, the purpose is still there, which is to materialize the subfunction. Here we can see for flowing, a front barrier is still used, which consists of railing types and a big hole at the bottom. This is to allow the big waste to go into the hole while the top part filters the water. Okay, however, the waste is not stored as before. Instead, a net is used and attached behind the front barrier. The waste that pass through the big holes then trapped inside the net. For filtering, the rear barrier also used as before, which consists of only railing design. The sensor still used in this design is in order to detect the waste accumulated inside the net so that the operator could collect them when it is needed. The operator only has to take out the filled net and replace it with a new empty one. The pump is also used the pump is used to pump water in the drain quickly so that the water can flow smoothly inside the drain. However, the position of the pump has been adjusted. The current location proved to be more effective since the water will rise at the front area of the system.
This is the screening metric result for each of our group, and in this screening matrix, Aiman design has been set as the datum, and for the weightage, it has been placed according to our PDS. And for this screening matrix, Arief design have the highest score of 17 compared to others design. After the scoring and screening matrix, this is the sketching of our final concept. And after the sketching, we develop the design into SolidWorks using the assigned material. For the FMA and FMEA, these are the table for the material that being used, categorized according to their sub-assembly, and it also show the part we able to reduce. This is the continuation from the previous table. This table is the continuation from the previous table, and as you can see from for the pumping, we not able to reduce any parts because by reducing any parts from here, we will disturbing its performance and the strength of the product itself. This is the FMEA table for all the 4 sub-assembly: flowing, censoring, filtering, and storing, and lastly pumping. This table shows the potential failure effect and the action needed to be taken, and all these issues have been assigned to the person in charge as shown in the table. This is the part that we'll be using in our product. First is the diaphragm electric water pump motor that we'll be using to transfer the water from the front barricade to the rear barricade. Next is the ultrasonic sensor to read and monitor the water level and also to trigger the water motor to be operated. And lastly, the front and rear barricade to contain the waste collected in the drain. And for the assembly, and as you can see, the first is the electrical component that being assembled, and lastly is our prototype.
Before we go through the engineering analysis, we have to know our properties of material. So this is the properties of mild steel and stainless steel. These are the parameters for us to calculate the static structure of the system. These are the parameters involved to do the static structure analysis. We have the cross-section area of water flowing through the system, pressure of flash flood through the system, and the velocity of flash flood. Using these 3 formulas to calculate the force act on the system. Then our design factor is 2 because it is a commonly used minimum value for many types of high-duty structures. Although higher safety factor means stronger structure, but also higher in material cost. The safety factor is used to calculate the maximum yield strength that the structure can withstand by divide the safety factor. So for mild steel is 185 megapascal, while stainless steel is 103.5 megapascal. All the parameters calculated at the previous slide is used to do the static structure analysis by using Answer software. The first structure is railing and the maximum stress add on this part is only 5.316 megapascal, which is far lower than the maximum yield strength of the material. This indicates the part is safe during the flash flood. Currently, the structure is front barrier, and the maximum stress on this part is 10.101 megapascal, which is also lower than maximum yield strength of the material. This indicates the part is also safe during the flash flood. Lastly, the structure is back barrier and the maximum stress on this part is only 15.457 megapascal, which is also lower than the maximum yield strength of the material. Again, the part is also safe during the flash flood.
This is the prototype of our product, and it have all the function as an actual product. So this product will be bring to IDEX 23, and the next video will be the demonstration of our prototype.